After we are done with load runner controller, performance test execution and scenario, next thing, and which is very important, is to find the problem area which is responsible for performance degradation so as to improve the performance of the server and achieve our goal. We saw in earlier section that when we create goal oriented scenario, we set some of the goals, whether it is hit per second or page downloaded per second or transaction time or whatever it is. To achieve that performance goal oriented scenario, we have to identify the problem. To improve the performance, we have to find the problem area. We have to optimize the system. So in order to improve the performance, we have to identify the problem responsible for degrading the performance of the server or the application. Now, the problem responsible for degrading the performance of the server or the application is known as bottleneck. You might have seen that sometimes application runs very slow on internet with very heavy load at peak time, and sometimes application don't respond when we enter URL on internet. So this is due to bottleneck. This is due to a problem responsible for degrading the performance of the server or the application. Now, it is important to understand when bottleneck occurs. Bottleneck occurs only when system resources reach its maximum capacity, after which it causes the system to slow down. System resources such as disk, CPU, memory, process, or network. It might be overutilized due to heavy load. In the given system configuration, if there is heavy load which the system is unable to withstand, then performance degradation occurs. It may be due to insufficient or misconfigured resources, malfunctioning components, or incorrect request for resources by program. Now, there are some major areas which we focus in order to find out the bottleneck. There are 5 major areas that is mainly responsible to cause the bottlenecks and affect server performance, which are given as below. Physical disk, it is related to storage, memory, RAM. Sometimes in order to quickly do processing, RAM is required. So if that is overutilized, then it also causes bottleneck. Processes, so many processes occurs, any process could be causing bottleneck. High CPU value such as 80%, 90%, 100%. You might have seen that system is showing utilization of 90%, 95%, 99%, causing it to be hanged. Network issue, there might be congestion in the network, so many requests in the network, which could lead to blockage of traffic leading to bottleneck. Now, if any of the resources are overutilized, it can degrade your server or application performance and can make it very slow or even crash the application. Now, there are many performance metrics available. such as response time, transaction per second, transport bytes, etc., which are available during test execution in LoadRunner controller. So these are performance metrics: response time, transaction per second, transport byte, etc. These are performance metrics which are available during test execution in LoadRunner controller. But there are many more metrics required. It is also very important to see the impact of test on the tested hardware and software. You have to do performance testing on different hardware and software configuration. There are many metrics available related to hardware utilization, CPU, disk I/O network, and software counters. There are many software counters available, which are typically interesting metrics to access system performing better. Now, the best way to collect resource usage data is to connect performance center with HP Cytoscope. So you can install HP Cytoscope on the controller machine itself or on the server. So it will collect all the required counters, all the required information from the server, whether it is related to CPU, disk, I/O network, software counters. So all things will be captured by HP Cytoscope and sent to the LoadRunner controller. Now we are at even if we are not having Cytoscope license, it does not mean you have no option to resource monitoring for resource monitoring. Even if you are not having Cytoscope license, so it is separate license is required for it. So even if you are not having license of it, you can even then do resource monitoring. Performance center includes support for number of architecture: Unix, Windows, web server, application server, database server, SNMP. So we can add the graphs here. Since it is trial version, we are unable to see. In this graph we can add measurement and do all the things, all the stuff. Since it is trial version, facilities are not available, we are unable to see graphs. Since we are using trial version of LoadRunner controller, we should understand some of very important counters which are generally measured to find out problem areas or what is called bottleneck in terms of performance testing. So the better problem area in performance testing which causes the degradation, we call it bottleneck in performance testing. Now Performon, we can see them using Performon. Performon is available for all the Windows machine. It displays all the results which are available with Cytoscope and available on Windows machine. Before seeing them in live session, first of all we should see some of the important counters related to memory, process, CPU and network as given below. So we can configure. Performon is available on all Windows machine. Suppose this is my server. So to see some of the counter related to memory, process, CPU and network, what we will do, we will open Performon counter. This is performance monitor we have opened. Now we need to see counter related to memory, process, CPU, network. There are many more counters which we need to see. So these are some of the important ones. It's not limited to this only, memory, process, CPU and network only, but these are the main counters which we see. Memory counters. This describes the amount of physical RAM available to process running to the system. means available. This is available M bytes. Amount of physical RAM available to process running on the system. Now it should be available in sufficient quantity so that all the processes can run required processes. Now result to watch for. So let us see in performance counter. These are performance counters. You see this is processor time counter. We can add performance counters as well. Let us see where memory is located. Available M bytes. So this is counter. So available M byte consistent value of less than 20 to 25% installed RAM is an indication of insufficient memory. Value below 100 MB may indicate memory pressure. So if the value is less than 20 to 25% means memory is less. So we have to focus on this. The counter displays the last observed value only, it's not an average. Let us see here. We can add perf one in using controller. In trial version this facility is not available. So let us see, this is memory. Let us see its counter. See available bytes, available M bytes. What is available M bytes? You can see the description also to have understanding of it. Available M bytes is the amount of physical memory in MB available for allocation to a process for system use. We saw it there also. This was the information, amount of physical RAM available to process running on the system, and it should not be less than 20 to 25%. So we can add this counter as well. So if you want to add this counter, available M bytes, you want to add, you can add, you can click on OK, and this is available M bytes counter, and you can see its result. It's if it is less than 20%, 25%, then it shows that memory available is less. So it should be less than 20 to 25%. So this is the way how we add counters in Pokemon. Memory pages per second. This is another counter of memory. Indicate the rate at which page are read from or written to disk to resolve hard page faults. Now what is page fault or paging? Paging means blocks of data from RAM is shifted to hard disk if the space in memory is or in RAM is less. So this is called paging, and it is not a good thing that paging should occur. Paging should not occur at all. There should be sufficient memory. If sufficient memory is not there, then it will lead to paging, and it will lead to pages per second. Indicate the rate at which pages are read from or written to disk to resolve hard page faults. Now, threshold to watch for page per second higher than 5 indicates a possible bottleneck. If this value is 0, then it's well and good, and if it is higher than 5, then it is a great problem, and it may be possible bottleneck. Pages per second. Let us see in the memory where is pages per second. You can see it here also. There are all important counters available here. So you can see page faults and this that. So these are all the counters that may be required to be monitored. page faults per second. You can see it here. You can see the description. Average number of pages faulted per second. So it should be less than 5. So these are the counters. Now, if for process private byte total indicate the current allocation of memory that cannot be shared with other process, the counter can be used to identify memory leaks in .NET application. So these are counters which we need to understand and use to find out bottleneck. Memory leak is nothing but shortage of memory in the application. The application may require more memory, but there is shortage of memory. So this is memory leak. It is a it can be described in more detail, but just for now we have to understand that shortage of memory in the application is memory leak. Process working set. This is amount of physical memory being used by all processes combined. If the value for this counter is significantly below the value of process, private byte underscore total indicate the processes are paging too heavily. A difference of more than 10% is probably significant. So these are all available here in the counters. Just now we need to understand and use it wisely. Now processor counters or process counter or processor counter. CPU related to CPU. Total stand percentage of elapsed time a CPU is busy executing a non-idle thread. Processor percentage time of sustained or over 85% may indicate that processor performance is the limiting factor. If the CPU goes above 85%, so it may be cause of bottleneck. We have seen it already in our practical life. While we are using system, sometimes it happens that processor goes to 85%, 90%, 95%, causing system to hang. It is not a good condition. Processor time should be less. Privilege time, percentage of threads running in privilege mode, file or network IO or allocate memory. Percentage privilege time consistently over 75% indicate bottleneck. Processor queue length. Let us see some of them in the perform processor. Processor. Let us see privilege time, interrupt time, processor time. You can see you are seeing the terms here. Percentage privilege time, processor time. You can see here privilege time, processor time with description. We have to see the description and use it wisely. Seeing the threshold value of the threshold value should not exceed the given value here. Like percentage processor privilege time should not be greater than 75%. Processor queue length should not be greater than 2. If it is greater than 2, it indicates bottleneck. Like 91 to 100% processor related counters indicate critical or out of specification. So these are the things that has to be focused on. While we are dealing with counter, we have to understand the threshold value, and if it is at the threshold value or above the threshold value, then it is a big problem. System context switches per second. It is important counter of system. System is let us see system. So what are the things that can be in system? we look into the system also, it is one of the counter available in the system. This is system. You can see in system also there are lots of counters available. This is context switches per second. Context switches per second is combined net at which all processes on the computer are switched from one thread to another. Context switches occur when a running thread voluntarily relinquishes the processor is preempted by higher priority ready thread, or switches between user mode and privilege mode to use executive or subsystem services. This occurs when high priority thread preempts lower priority threads that are currently running and can indicate when too many threads are competing for processor time. So it is not a ideal scenario. If merge processor utilization is not seen and very low level of context switching are seen, it could indicate that threads are blocked. So there should be proper processor utilization, and there should be context switching should be more. Low level of context switching means there is no higher priority threads does not preempt lower priority threads, and lower priority threads are running and higher priority threads are waiting. So it should not be the case. So threshold to watch for in this case is, as a general rule, context switching rate of less than 5000 per second per processor are not worth worrying about. If context switching rate exceeds 15,000 per second per processor, then there is constraint. So the context switching, if it is low, then there is no problem. But if it is more and more higher priority threads are preempting lower priority threads, that means they are blocking the threads. So it should not occur. If context switching rate is more, like exceed 15,000 per second per processor, then it is a constraint. Now discounter is related to storage, disk storage. Here you can see the counters also for the disk. Let us see. You can see physical disk is here, percentage disk read time, disk write time. All these are counters. Physical disk instance, disk transfer per second. You can see here disk per second read, disk per second transfer. So these are the counters. Disk write queue length, current disk queue length. So these are all the counters which we need to monitor. Average disk second transfer, you saw it here. Average disk second transfer. Average disk second slash per transfer. So these are the counters we need to see. To monitor disk activity, we use this counter. When the measurement goes above 25 disk IOs per second, then we go poor response time for the disk, which may well translate to a potential bottleneck. To further uncover the root cause, we use the next mentioned counter, physical disk instance, percentage idle time. This counter measures percentage time that the hard disk is idle during the measurement interval, and if we see the counter falling below 20%, then we are likely to get read write request going up for the disk which is unable to service the request in a timely fashion. In this case, it is time to upgrade the hardware to use faster disk or scale out the application to better handle the load. If the disk is slow, then we need to replace the disk. So using this counter, we can find out whether the disk is working properly or need to be replaced. Every disk second per transfer, we saw it in per month. The number of seconds it takes to complete one disk input output for reading or writing or whatever IU operation we have to do. So this counter indicates, sorry, this counter indicates the number of seconds it takes to complete one disk input output operation. Every disk second per read, the average time in seconds of a read of a data from the disk, average disk second write, the average time in seconds of a write of a data to the disk. Now less than 10 millisecond is very good to read the data from the disk. If it is taking less than 10 milliseconds, it can be considered very good. Between 10 to 20 milliseconds, it's okay. 20 to 50 milliseconds, slow, need attention. Greater than 50 milliseconds means it's a bottleneck. Serious issue. Network counters. So the network counters also problem in network, congestion in the network, blocking the traffic. So how we will we find it? Network interface output queue length. This is the number of packets in queue waiting to be sent. A bottleneck needs to be resolved if there is sustained average of more than 2 packets in a queue. There should be no package in the queue. It should be going or coming. It should not stay, and there should not be sustained average of more than 2 packets in it. Result to watch for. If greater than 3 for 15 minutes or more, network interface card is bottleneck. If there are 3 packets that is still there in the network for 15 minutes or more, which means that there is bottleneck. There should be no queue maintained. Means traffic should be flowing. Network segment percentage network utilization. Percentage of network bandwidth in use on this segment. Threshold to watch for. For Ethernet network, if the value is consistently above 50 to 70%, this segment is becoming bottleneck. So network bandwidth utilization should be less than 50 to 70%. It should be less. More it is less, more it is better. You can see network counters here as well. Network interface. You can see byte received per second, byte change, current bandwidth. You can see here. You can see all the counters here. Network related counters available here. Packet sent received. So all the output queue length. Here it is output queue length is there. You can see output queue length, this counter. So this type of counters is measured using perf We can integrate controller with perf In the trial version, it is not available. We are unable to show you. So now we are done with the counters. So it is not limited to these much counters. These were important counters, but there are still many more counters related to which we need to monitor. So those will come with the experience. We do application and database profiling as well, query optimization as well. There are many more things that is done, but these were the important counters that are generally seen and most commonly used for discovering performance bottleneck. Now, one very important thing to be noted here is that we need to have proper licenses for monitoring the server, be it either web application, web server, or application server, or DB server. We need to have proper licenses for monitoring these servers. But even if you are not having the license for any of these, you can still monitor Windows resources using Perpmon. If Perpmon is available on the server, we can add it in controller. There are features. There is a feature in LoadRunner controller which enable LoadRunner control to call the Perpmon DLL, and counters can be added to monitor the behavior of the whatever workstation that is needed. We saw all the performance counters now, important performance counters. So we can add Perpmon in using LoadRunner controller. Since we are using trial version, we are unable to show it here. So we can get this counter measurement in the controller itself. Since we have trial version of LoadRunner controller, so we cannot show here how to add measurement from the remote server. But in case you have licensed version of LoadRunner controller, then you can add monitor server machine from the state given below. Open LoadRunner controller. We will open LoadRunner controller. Select system graph. Since graphs is not available, we can select system graph from here. Double click on Windows resources. Right click on Windows resource graph area. We need to right click here, and here add measurement option would be shown. And since it is trial version, is not showing, so we will add measurement at the monitor server machine. I will add monitor server machine here. Click on add button. I will enter machine name or IP of the server machine. Select its platform and give username or password, whatever it is required, and click on OK button. It should add server machine to be monitored, to be connected with the controller to get important performance counter information. All the issues related to CPU, memory, network, input, output, disk storage, all the things mainly related to hardware are monitored in this way. So these are important. We do application profiling and database profiling as well. So these are so this is a separate topic. And while application profiling is we use JProfiler, JPro for Java application. We use Ant Profiler for .NET application. We can optimize query in the SQL. So there are many things which we can learn while we will be doing performance testing. These are simple things which we can learn. So these are the things which we need to monitor to find out bottleneck and remove bottleneck and improve the performance of the application to achieve our goal related to performance testing. Thank you.